Any course that's steeped in physics requires a base knowledge of what a scalar is and what a vector is. Hopefully this is just going to be a repeat video if you've taken physics courses before. If not, you really need to do some research on your own and get familiar with these terms. So a scalar, by the book's definition, is a quantity whose value may be represented by a single positive or negative real number. And some examples of these include temperature, length, and mass. A vector, on the other hand, is a quantity that has both a magnitude and a direction. So typically this is represented by an arrow. It has some magnitude to it, and it's going in some direction in space. Some examples of this are force, velocity, and acceleration. Force has to have some sort of direction associated with it. You can't just say, I'm pushing on this table with 5 newtons of force. You got to give it a direction. And one of the things that might stick out is velocity. And you may think, velocity, is that really a vector? And the answer is yes. Actually, velocity physically is a vector. This is the classic debate over velocity versus speed. So if someone asks you how fast you're traveling, right, in a car, they're typically talking about the speed which you're traveling at, which would be a magnitude. So that could be a scalar, is speed. Velocity, on the other hand, has a direction associated with it. So if someone asked you what's your velocity, you could say I'm going 60 miles an hour south. And one of the other things we have to introduce is a field. And I'm just going to give you a forewarning. Fields are the first place which students in this course automatically get confused. But it's really not that difficult to understand. The book defines a field as a function that connects an arbitrary origin to a general point in space. And to this definition, I have to say, what the hell does that mean? You need to know that a field is normally associated with some physical effect in a given area. And there's two main things to look at here, physical effect and given area. Physical effect could be something like gravity. A given area means that your field has to be defined for every point in a given region. And there exist both scalar and vector fields. So scalar fields are things like temperature in a bowl of soup. This is the example that the book really likes to use. Or even the density of the Earth. And what these fields do is they relate a position, and depending on the problem and depending on the field and the physical phenomena, a time to a scalar value. So to look at the temperature in a bowl of soup, if I asked you what's the temperature of the center of a bowl of soup after 5 minutes of cooling down, knowing some initial conditions and some boundary conditions and things like that, you would be able to actually set up an equation and solve for it, and your result would be a positive or negative number. A vector field, on the other hand, is things like a gravitational field, a magnetic field. And these fields relate a position and possibly a time to a vector. Something like, what is the force of gravity at the top of Mount Everest? And once again, just to clarify, the force is actually the force of gravity, and it's pulling you towards the center of the Earth. It's pulling you towards the mass. And given your position relative to the center of mass of the Earth, you're able to actually calculate the force of gravity on the top of Mount Everest. Some visual examples of these are pretty useful in understanding what's going on. So we have a scalar field over here, which is something, say, like a temperature distribution in a brick that you heated up. And if I were to ask you to take a x position and a y position and tell me what the temperature is, you'd be able to do that. And if you look at it, with the values that they give you, you can see that it actually is a scalar value. As compared to this vector field over here, if I gave you a position, so let's say an x position and a y position, you'll see that you land on a vector. And what's interesting is that if you change your x and y position, look how differently the vector changes. We're going to see both of these types of fields, and we're going to be seeing scalars and vectors a lot. So it would be really in your best interest to do some independent research if you're not comfortable with these topics before moving on.